right, we are to our last video presentation, and in this particular video, we are going to talk about the last transformation that we can do, which is going to be reflections. And then we're going to bring it all together and look at equations or graphs that include everything that we've talked about so far. All right, so the last thing that we have is something called reflections. And so the easiest way to kind of think about reflections is just think about our basic line goes up from left to right. In order to make it go down from left to right, we want to have a negative. Same thing with parabolas. And when we talked about parabolas before, remember that if our leading coefficient was positive, it opened up. When our leading coefficient was negative, it opened down. And so that's what we talk about that's what we're looking at when we talk about reflections. Now, technically, there are two reflections. The first one we have is going to be a vertical reflection. And so a vertical reflection, we are going to have a negative outside our function. And what this does is it reflects the graph across the x-axis. We want to multiply all of our y-coordinates by -1. When we see these in the homework, when we're actually talking about what it's doing, quite often you will see this terminology. You won't see vertical reflection. You will see reflect across the x-axis. And so we're going to talk about, okay, well, how are we going to keep that straight? The second one that we have is going to be a horizontal reflection. And again, here, because it is horizontal, it is going to be on the inside. And just like all the other horizontal stuff we do, we are affecting the x-coordinates. We want to multiply all of our x-coordinates by -1. When we talk about this in terminology, remember we're not going to say horizontal reflection. What we're going to say is reflect the graph across the y-axis. All right, so I'm going to kind of show you the way that I remember this, and it's a little difficult to do in a video, but we're going to go ahead and kind of see what this looks like. All right, we are going to start with just, instead of working with a basic function, we're going to start with a picture. And we want to go ahead and talk about our reflections here. All right, so when we look at this first example, let's go ahead and make a table of values to get us started. And so our table of values, we have the point -2, 1. We have the point -1, -3. We have the point 0, -1. We also have a point 1, 0 that is right here. And we have a point 3, 2. I'm going to include that point 1, 0 just so that we can kind of talk about some of our x-intercepts and our y-intercepts. All right, so now when we look at the first example, notice we have a negative on the outside, which means that I want this to be a vertical. Vertical affects the y values, and so we want to multiply all of our y values by -1. My x values are going to stay the same, so we still have -2, -1, 0, 1, and 3. And we want to change the signs of the y values. So 1 becomes a -1, -3 becomes +3, -1 becomes +1, 0 stays 0, and 2 becomes negative 2. All right, when we go ahead and plot these, we have negative 2, negative 1. We have negative 1, 3. We have 0, 1, 1, 0, and 3, negative 2. We connect the dots. And this is what we get. And so when we talk about what did we do, is basically everything here is going about the x-axis. So that's what we mean when we say reflect about the x-axis, is we are going up and down. Everything on top goes to the bottom. Everything on the bottom goes up to the top. All right, let's go ahead and look at the second one. And for the second one, we want to do h of x equals f of negative x. And so for this one, we have our negative is on the inside, which means that I want to change my x coordinates. And so when we change our x coordinates, again, we're going with the original table. Negative 2 becomes a positive 2. Negative 1 becomes positive 1. 0 stays 0. 1 becomes negative 1. And 3 becomes negative 3. And for this one, we keep the y coordinates. All right, so I'm going to go ahead and graph this one in red. And I'm going to go ahead and let's go ahead and erase, because I don't have a second. I don't know what happened to my coordinate axes. And so when we graph this, we get 2, 1, 1, negative 3, 0, negative 1, negative 1, 0, and we have negative 3, 2. And so when we connect the dots, we get something that looks like this. And for this one, what we're actually doing is we are moving everything from the right to the left, and everything from the left to the right. And so this is a reflect about the y-axis. Notice here that my arrows, my directions, are going around the y-axis. All right, so that is our reflections. Okay, so now let's go ahead and bring it all together. All right, so the main thing that we want to focus on here is we want to focus on vertical and horizontal. Remember that we talked first about vertical shifting. And remember, vertical shifting is adding or subtracting on the outside. These affect the y-coordinates. We do exactly what it says. If it says add, we go in the positive direction, which is up. If it says subtract, we go in the negative direction, and we go down. We also had vertical stretch and vertical compress or shrink. And remember that these are numbers that we are multiplying by. And again, we do whatever it says. If it says multiply by a larger number than 1, we multiply. If it says multiply by a number smaller than 1, we divide. When we stretch, we are basically moving the points further away from the x-axis. And if we are compressing, we are moving the points closer to the x-axis. We also had our vertical reflection. And again, it's on the outside. And this is where we multiply all of our y-coordinates by -1. And we are reflecting across the x-axis. Basically, we are going from top to bottom, bottom to top, and that's what we're doing here. The other one that we had was horizontal. And again, horizontal, we are doing, it is going to be on the inside of our function. And remember that we do the opposite of what it says. If it says minus something on the inside, we want to go in the positive direction. If it says plus something on the inside, we want to go in the negative direction. And similarly, for our horizontal stretch and our horizontal compress. If we have a small number, we want to make it bigger. We want to move further away from the y-axis. And if it's a large number, we want to move closer to the x-axis. So if it says divide, we want to multiply. If it says multiply, we want to divide. We have horizontal reflection. And this is when we have a negative on the inside. And note that multiplying by -1 and dividing by -1, they're the same thing. So technically you can think of this as doing the opposite, but we still get the same thing. We are reflecting across the y-axis. And so when we look at this, we are going, left goes to the right, right goes to the left. All right, finally, because we are going to be combining a bunch of things together here, we do want to know our order of transformations. And this is something that, this is the general order. We can do things, and we're going to see an example where it kind of changes. In general, our order of transformations is going to be this. We want to start with our horizontal shifting. Meaning we add or subtract our x values. Then we do any stretching or shrinking and reflecting. All of these are our multiplications, and so there's really no order in terms of how we have to do them. And so you can think of all of these as basically being one thing. And finally, we want to do vertical shifting. When we write out the order that we do these things in, this is the order that we do want to state them in. We do want to start with our shifting, we want to do our stretching, compressing, and reflecting, and then we want to do our vertical shifting. And it can make a difference because, for instance, if you stretch before you shift, then these points are not going to be on the same spot. And so we do need to be careful about that. All right, let's go ahead and look at some examples of this. And we are going to talk verbally about what is happening to our graph. We are going to look at our tables, and we are going to, of course, look at this visually. All right, so let's go ahead and look at our first couple of examples here. Again, remember we're going to be doing several things to these equations. And so the first thing we're going to talk about is, let's talk about what happens. Okay, remember our order when we talk about these. The first thing I want to know is, do we have any horizontal shiftings? Our basic function is a square root function. Do we have any addings or subtractings inside? The answer is no. Okay, so now we can go over to our stretching, compressing, and reflecting. We don't have any horizontal stretching, compressing, or reflecting because, again, the only thing inside my square root is an x. But we do have some vertical stuff going on. And so the first thing that we have going on with this is I do have this 1/2 on the outside. And what this tells me is I have a vertical compression of 2, and again, you can also say 1/2. I'll accept either one of them. We also have a negative on the outside, and so what this is this is going to be a vertical reflection. And when we talk vertical reflection, remember we're going, everything on top goes to the bottom, everything on the bottom goes to the top, and so we are reflecting about the x-axis. All right, so that's what we've got going on here. Okay, so now let's go ahead and create our tables. We're going to start with our basic table for square root of x. And remember that with this we go 0, 1, and 4. And when we take the square root of each of these numbers, we get 0, 1, and 2. All right, now we want to go ahead and apply these two things. And if you want, you can do them simultaneously because they're both multiplications. What we essentially want to do is we want to multiply our y-coordinates by negative 1/2. And so when we do this, our x-coordinates stay the same. They are going to stay 0, 1, and 4. I want to multiply my y-coordinates by 1/2, so we get 0 times 1/2 is 0. And if we multiply that by a negative, we also get 0. Same thing with our 1. If we multiply 1 times 1/2, we get 1/2. We change the sign and we get negative 1/2. And if we do that with the 2, we take half of 2, we get 1. We change the sign and we get negative 1. So whether you do this in 2 steps or in 1 step, that's up to you. All right, so now let's go ahead and graph this. We're going to start with our original function, which was 0, 0, 0, 1, 1, and 4, 2. We graph our new function, we get 0, 0, 1, 1/2, and 4, negative 1. We graph this. We get something that looks like this. So we have that our points are closer to the x-axis and they are moved to the bottom. All right, that's our first example. Let's look at a couple more. All right, let's come down to example B. And we are going to start by talking about, okay, what happens with let's talk verbally about what's going to happen to our graph. All right, the first thing we want is horizontal shifting. And so we are going to start with our -2 on the inside. All right, so what does that tell me to do? I have a horizontal shift. It says -2, but what this means is, remember, we always do the opposite. And so we are going to go right 2. The next thing that we have is we have this minus sign. In front of the X. This is a horizontal reflect. Because it is a horizontal reflect, remember that we are changing our X values, which means all the points on the left go to the right, all the points on the right go to the left, and we are reflecting across the Y-axis. All right, the next thing we want is, that takes care of our horizontal reflect, and that's all we have in terms of our multiplying. On the outside, we are not multiplying by anything, and so we don't have any vertical stretching, shrinking, or reflecting. The last thing that we have in our function is we have a -1 on the outside. And so what this tells us to do is we have a vertical shift. And remember, vertical, we do what it says. And so we are going to go down 1. All right, let's go ahead and start with our original table. If we have 0, 1, and 4, we get 0, 1, and 2. Now, for if you do have shifting and reflecting and or compressing working on the same thing, you may want to do this in 2 steps. So the first thing that I'm going to do, and keep in mind that we can have as many tables as we want. I'm going to call this Y1. And so what I'm going to do is I'm going to shift 2 to the right. So remember, this is where we want to add our x's plus 2. So we're going to get x's 2. We add 2 onto 1, we get 3. We add 2 onto 4, we get 6. And because we are only doing the x's, we're going to leave our y's alone. All right, the next thing that I'm going to do is I am going to take care of my reflection. And so remember, we want to have a reflection on the inside. So I want my x's times -1. And we're going to work with the x's from that new table. And so if we multiply by -1, we get -2, -3, and -6. For this one, I'm also going to do my y's at the same time because they're not connected. Okay, I only do a couple tables if we're talking about connected things, but because the y's are not connected to the x's, we can do these at the same time. And so remember that we are wanting to do our y's minus 1. And so if I go 0 minus 1, I get -1. And if we do 1 minus 1, we get 0. If we get 2 minus 1, we get 1. And this here is going to be the table that we want to use when we draw this out. So we have our original function, our parent function, and then we have the final function. All right, if we go ahead and graph this, my original function, we have 0, 0, 1, 1, 4, 2. We get something that looks like this. All right, my new function, we are going to start at -2, -1. We have -3, 0. And we have -6, 1. So notice that what we have done here is I have shifted all of my points to the right 2. I have then reflected them across the y-axis, and then I have shifted them all down 1. And that is how we get our new function. All right, that takes care of these two. Let's go ahead and play with a couple more. All right, so now let's go ahead and apply these techniques to just a picture. We're not going to look at a basic function. All right, so we are going to start with our initial table. And so let's see what we can do here. We have, for our initial table, we have x and f of x. We have the points -2, 0, -1, 2, 0, 0, 1, -2, and 2, 0. All right, so when we look at our first example, we already looked at something like this in section B5. This is just going to be a couple shifts. And so here, what we have is inside our parentheses, we have a +2. And so remember the +2, this is going to be a horizontal shift. We do the opposite. And so we're going to do our x's -2. On the outside, we have a +1. And so our +1, this is going to be a vertical shift. We do what it says. And so we are going to do our y's +1. This up here was left 2. And our y's, we are going to go up 1. All right, so if we go ahead and create a new table, Again, we have our x's minus 2. And so all of our x values, we want to subtract 2 from them. When we do this, we get -4, -3, -2, -1, and 0. For our y's, we want to do what it says. So it says we want to add 1 onto the y's. And so when we do this on each one of these, we're going to get 0 plus 1 is 1, 2 plus 1 is 3, 0 plus 1 is 1, and -2 plus 1 is -1, and then finally 0 plus 1 is 1. All right, when we plot these, we have -4, 1. We have -3, 3. We have -2, -1. I'm sorry, -2, 1, -1, -1, and 0, 1. We connect our dots, and we get this. And so notice that on this one, what we have done is we have moved all of our points to the left 2, and we have moved our y up 1. All right, let's go ahead and try a couple other examples. Okay, so if we come down to B, again, we want our original function. Our original function was, we had -2, 0. We had -1, 2. We had 0, 0. We had 1, -2. And we had 2, 0. All right, so now let's go ahead and look at example B. Example B, we do not have anything inside our function, which means that our x's are going to stay the same. Again, I'm going to do this in 2 steps. And so my x's stay the same. The first thing that we want to take care of is on our y's, we want to, remember, do our stretching, compressing, reflecting, and then we do our shifting. And so we are going to start with the negative that's on the outside, and this is a vertical reflection. We are going to be going top goes to bottom, bottom goes to top, and we are reflecting about the x-axis. So we want to change all the signs of our y-coordinates. All right, zeros are going to stay zeros. +2 becomes a -2, and -2 becomes a +2. All right, so this is just my reflection. The second thing that we want to do is we want to go ahead and shift. We have a -1 on the outside. And so what this means is I want to take my new function and I want to shift down 2. It is a vertical shift. We do what it says. And so we are going to go ahead and again, we keep our x's the same. This is going to be our final y. This is going to be the actual one that we want. And we are going to take all of our y values and we want to subtract 1. Our first one, we did y's times -1. All right, so if we shift down, 0 minus 1 is -1. -2 minus 1 is -3. 0 minus 1 is -1. 2 minus 1 is 1. And 0 minus 1 is -1. All right, if we plot these, let's see what happens. We get -2, -1. We get -1, -3. We get 0, -1. 1, 1. And 2, -1. We connect our dots. And we get this. When we compare it to the original function, again, we are going a reflect, and then we are going down 1. All right, let's come to the last one. All right, so we have our original function again. We have x and f of x. We still have our original points. And so now for this one, let's see what we got. Do we have any horizontal shifting? And the answer is no. We don't have any addings or subtractings inside the function. Do we have any horizontal stretching, compressing, or reflecting? And we do. And so the first thing that we have here is we have this 2 on the inside. Remember that we want to do the opposite of what it says. And so this is going to be, instead of multiplying our x's by 2, we want to divide them. And so it is going to be a horizontal compress by 2 or by 1/2, depending on how you want to think about it. All right, so what does that do to my x's? We're going to divide all of our x's by 2. So -2 divided by 2 is -1. -1 divided by 2 is -1/2. We get 0. And when we divide the other ones by 2, we should get 1/2 and 1. I'm going to go ahead and do my second thing at the same time, just because they are disconnected. And so on the outside, we have a +2. And so remember, this is going to be vertical because it is outside. We do exactly what it says, and it's telling us to multiply by 2, so this is going to be a vertical stretch, and we want to go by 2. So if we take our y values and multiply them by 2, we get 0, 4, 0, -4, and 0. All right, and we're ready to go. So let's go ahead and see what this looks like. This one gets a little hard to draw just because we're squishing one way and we're stretching another way. We have -1, 0. We have -1/2, -4. We have 0, 0. We have 1/2. Oh, I did that wrong. I'm sorry. Okay, let's try this again. We have negative 1, 0. We have negative 1/2, 4. We have 0, 0. We have 1/2, negative 4. And we have 1, 0. And so what we're doing is we are squishing it from side to side, and we are stretching it vertically. And we should get something that looks like this. All right, let's try a couple more examples. The next thing that we're going to look at is we are going to go ahead and talk about looking at an equation, or we're going to want to create an equation. And so if we look at this first one, we have our basic function is f of x equals square root of x. Again, we want to change our function name just because we cannot call this f of x. And we have square root of something. Okay, so let's break down what we have here. The first one we have is shifted right 4 units. Okay, so it's a shift, which means I want to add or subtract. We are going to the right, which is horizontal. We want to do the opposite. And so if we're moving to the right, we're adding 4, which means that on the inside of my function, I want to subtract 4. All right, the second thing that we have is we have reflected about the x-axis. And so when we visualize this, again, it doesn't tell us whether it's horizontal or vertical. If we look at this, this is my x-axis, and if we are reflecting it about the x-axis, this is going to be a vertical reflection. And so we want a negative outside of our function. And we're done. That is our function that we want. All right, the next one, let's look at B, or the second example. All right, again, we have our original function is our square root. And let's see what it does here. Okay, we have shifted left 2 units. This is going to be a horizontal shift. And remember, we do, just a minute. Horizontal shifts are going to be inside, and we do the opposite. And so when we think left 2, that we should be doing subtract 2, which means that inside my function, I want it to be a plus 2. All right, the other thing we have is we have reflected about the y-axis. And so what this is going to be is, if we look at this visually, this is my y-axis. And if we're reflecting about the y-axis, we are going side to side. And so this is going to be a horizontal reflect. And again, it's going to be inside. And so remember, for horizontal reflection, we just put a negative, and so what we get is h of x equals the square root of negative x plus 2. All right, the next one, this is going to be the one that's kind of different. We do have to be careful because we start off with our original function, okay? Let's call this one k of x. And we do need to be careful because if you notice, remember that I said that we always do shifting first and then stretching, compressing, and reflecting. Notice here, that's not the order it's given in. And so we do need to be careful on how we do this. So we're going to start with our reflection. We have reflected about the y-axis. And this is going to be a horizontal reflection. It is going to be inside. And so we're going to have a negative here. The other thing that we have is we have shifted right 3. And so this is going to be a horizontal shift. It is going to be inside, and we want to do the opposite. And so right 3 is going in the positive direction, and I want to go ahead and make it a minus 3. Okay, now this looks very similar to what we did in the last example. The numbers are a little bit different. But here's the thing. How do we change the order of how we do these things? Well, if you recall in order of operations, how can we add before we multiply or divide? And the only way that we can do that is if we include parentheses. And that's exactly what we want to do. We want to put the x minus 3 in parentheses, and now this is going to do our reflection before we do our shifting. Let's talk about what this looks like using some tables. All right, if we look at the first one, okay, if we start with our point, and this is just going to be square root of x. Remember, we have 0, 1, and 4. We have 0, 1, and 2. Both of these are on the inside. And so recall when we talked about how do we do this originally, what we want to do is we want to set the inside equal to each one of these numbers. And so notice on the first one, we want to start by subtracting 2. This is our shift. And then we reflect by dividing by negative 1. Okay, so we shift, then reflect. On the other hand, if we look at the other one, if we do minus x minus 3 in parentheses equals 0, what we do is we divide by negative 1, this is our reflect, and then we add our 3, and we get our shift. And so it may not seem like a big deal, but just so you know, when we talked about that order in terms of how do we do our transformations, note that that's our basic order. We can always change things around if we want to. And so it is very important when you are describing your transformations that you are describing them in the correct order, especially when we talk about the horizontals, because if we don't have it in the right order, then our graph is not going to be the same. All right, let's look at two more. All right, let's go ahead and look at our next example. We're going to start with our basic equation. We're going to call it, let's call it n of x this time. Remember that our basic equation is just going to be square root of x. All right, so for this one, we have reflected about the x-axis. And so when I think about this, we are going this way. And so this is vertical. It is going to be outside, and it will be a negative outside. The next thing that we have is we have shifted left 2 units. And so this is going to be inside. It is horizontal. It is going to be inside. And left 2 means I want to subtract 2. And remember that we do the opposite. So instead of minus 2 inside my square root, I want it to be a plus 2. And there is our equation. Okay, the last thing that we have is we're going to increase the difficulty level just a little bit more. We're going to do 3 things on this one. All right, so let's go ahead and start with our function name. Let's go b of x. We still have our square root. And let's go ahead and break this down. So we are going to start with shifted left 2 units. This is horizontal. It is going to be inside. And it is going to be do the opposite. So because left 2 means I want to subtract 2, we are going to go ahead and make this a plus 2 inside my square root. The next thing that we have is we have stretched vertically by 4. So it tells us that this is vertical. It is a stretch, and remember that because it is vertical, we do what it says. And so stretching is a multiplication, so we are going to multiply by 4 on the outside. The last thing that we have is we have reflected about the x-axis. And so x-axis is going to be this one right here. This is going to be a vertical reflect. It is going to be outside, and we do what it says, and so we are going to add a negative right here. And we're done. Okay? All right. All right, so now let's go ahead and apply these transformations to something that we haven't really looked at in this section. They're kind of boring, but we can still apply these topics to linear functions as well. Okay, so we're going to go ahead and start by looking at, remember, our basic linear function is going to be y equals x. And the thing with linear functions is that we can look at these in lots of different ways. And so, for instance, let's look at the first one and talk about 3 different ways we can look at this equation using transformations. All right, so the first one that we're going to do is we are going to go ahead and start by talking about the slope of 2/3. So the first thing that we can do is we can think of this just as a vertical shrink or a vertical compress of 2/3. Because it is less than 1, we can consider it just one number. So we can vertically compress by 2/3. We have our negative on the outside. And so we can think about this as a vertical reflection. And we can say about the x-axis. Remember, if it's vertical, we're going top goes to bottom, bottom goes to top. And then we also have a vertical shift. Down 2. Okay, so this is the first one that we can come up with. We can do this a couple other ways as well. And so what I'm going to do is I'm going to rewrite this. And what I'm going to do is I'm going to rewrite this as -2. Inside parentheses, I'm going to put a 1/3 x. And then I'm going to go -2 on the outside. All right, if we go ahead and look at it this way, if you do simplify this, you do get the same equation back. And so what this is going to entail is we are going to have a horizontal stretch of 3. This corresponds to my 1/3 inside the parentheses. We can also go ahead and say that we have a vertical stretch of 2. We also have, again, a vertical reflection about the x-axis. And we also have a vertical shift down 2. You could also, if you want, we could have the negative on the outside. We could put the negative on the inside and make it a horizontal reflect around the y-axis as well. And so that negative can be inside, outside. The fraction, we can consider it a single number, or we can separate it into a couple numbers. All right, the next thing that we can do, let's try one more. So here is my original function again. All right, what I'm going to do this time is I am going to rewrite this as -2/3 x plus 3. If you distribute the -2/3, well, then you do get back the original function. I'm also going to separate this, and so I'm going to go 2, and I'm going to put my negative inside. No, I'm not. Let's just leave it like this. Mostly because I think it's going to hurt my head if I try to do any more. All right, so if we look at it like this, we do still have the vertical compress again. By 2/3. Oh wait, I better back up. Okay, I did that out of order. All right, we are going to do a horizontal shift of 3 left. We are going to have a vertical compress of 2/3, and then we have a vertical reflect across the x-axis. And so the important thing to note here is that we can do all sorts of crazy things with linear functions. We can break this up, we can, as long as the function remains the same thing when you simplify it down to the original one, then it's still the same thing. Okay, and all we're doing is we are applying these techniques of transformations to our slope. Remember, slope is rise over run. And so when we look at this other example here, we have a rise over run. We have a rise of 2. We have a run of 3. And we do have our vertical reflect, which is meaning one of them is going to be going down. And here I'm saying I'm having my y go down. Similarly, when we include the parentheses, is that we can go ahead and move our origin from where it starts to, we can think about this as going to go up on the first 2 that, or go down on the first 2 that we looked at. Or we can think about, let's move our starting point to the right, to the left 3, and we still get the same thing. All right, let's try one more. Let's come down to the last one. All right, we're going to start with the basic one. The basic one tells us that we have a 4 on the outside. This is going to be a vertical stretch by 4. And then we also have our plus 12 on the outside, which is going to be a vertical shift up 12. So this is the first way that we can think about this function. Another way that we can think about this is we can go ahead and rewrite this function as 4x plus 12. We can think about it being on the inside of the parentheses. It doesn't do anything, but we can still think about this as horizontal. And so for our second one, we can think about this as a horizontal compress by 4, or 1/4. And we still have a vertical shift up 12. All right, so now let's get completely crazy. Let's go ahead and rewrite this as 4 times x plus 3. Here, we have a horizontal shift left 3. And we have a vertical stretch of 4. Just to show you that we can do all sorts of things with this, let's now do y equals -4 times -x. I'm going to go -2 plus 4. If you simplify this, it is still going to give us back the original equation. We distribute the -4, we get -4 times -x is 4x. If we distribute to the constant, we get -4 times -2 is +8, and then we add 4, and we get back our +12. And so if we look at it this way, let's see what we've got. We start with our horizontal shift. So we are going to shift right 2. We are going to reflect about the y-axis. That's the negative on the inside. That's a horizontal reflection. On the outside, we have a vertical stretch. By 4. We also have a vertical reflect about the x-axis. It's a vertical reflection, so it's going to be going top goes to bottom, bottom goes to top around the x-axis, and we have a vertical shift up 4. Now, if you graph all of these different equations in your calculator, you will see that that's what we are doing. When we look at points, all of these are going to be doing the same thing. All right, that takes care of this particular video, and that finishes up Module B. The next module we will be looking at is Module C, which is going to be polynomial functions. And a lot of the stuff that we're going to talk about is just going to be extending the concepts that we've been talking about in these previous 2 modules, and just extending them to larger things. All right, thank you, and have a good day.